math problems. So online, what I did is I posted my notes and what we had on there. So what I'm going to do is I'm going to switch over to my overhead projector and I'm going to talk. And then after that, I'll unplug that and we'll talk through these problems together. So the first thing I want to do is let's look over the notes first. So what we're going to be talking about is we're going to be talking about Coulomb's law. So when we're talking about Coulomb's law, that is an equation that you will need to know. So we talked about electroscopes yesterday. And so now today what we're going to do is we're going to apply the information that we figured out yesterday. So Coulomb's law is the strength of the forces depending on the distance. The closer, the stronger the force. Stronger as strength of the charges of the objects increase. So we had electroscope yesterday, and the electroscope looks a little bit different from his apparatus that he created to be able to find out what the strength of it is. So that's what we're going to be talking about today. Adjusting my camera just a tad bit. Okay, so when we're talking about that, we have this apparatus, and this apparatus is a little bit different than the electroscope that we did yesterday. This one actually has a constructive sphere here and here, and it also has a counterweight here. And what he was doing is he was trying to measure the radius in between these two to find out what the strength of the electrical charge was. So the first thing that he did was doing the force depending on the distance. So he used this F is equal to 1 divided by the radius squared. Then he decided, all right, the force depends on the charge. So if A equals B, he would have to add a sphere C to be able to find out what the force between those two charges were. And then the Coulomb's law is the magnitude of force between QA and QB. The second part of what you were looking at had to do with these equations here. But the main one that I want you to look at is this Coulomb's law here on the very bottom. So if you look at this Coulomb's law on the bottom, this is what we're going to be using. So we're looking for force equals the K constant. So from now on in this section, you're going to use 9.0 times 10 to the 9th newtons times meters squared divided by c squared. So that is the important one that you're going to do. So what I'm going to do now is I'm going to do the first problem first, and then we're going to talk about it. And then we're going to go ahead, and then I'm going to go back to my screen so you can ask me some questions, because right now, as far as me using my document camera, what is happening is I'm not able to hear you. So I'm hoping to be able to fix that today. So I'm going to leave this on the screen for you. And so what we're doing now is you should have done your practice problems during the time that you had until now. And so what we're going to do is we're going to look at question number 9 in the textbook. We are on page 560. So on page 560, and I'm recording this, by the way, just in case. On page 560, it says a negative charge of a negative 2.0 times 10 to the 4th coulomb and a positive charge of 8.0 times 10 to the 4th are separated by 0.30 meters. What is the force between the two charges? So to be able to do that, what you're going to have to do is you have to first of all say, all right, my force equals KGA plus my QB divided by RAB squared. So I look back at my problem again, and I know that my K constant, which is down here, is 9.0 times 10 to the 9th newtons times meters squared divided by coulomb squared. Now my QA in the book, it told me it was 2.0 times 10 to the negative 4th coulombs. And it also told me in the book that my QB was 8.0 times 10 to the negative 4th coulombs. And I'm going to divide that by the radius of A to B squared. It said in the book that the radius was 0.30 meters squared. So what you would have to do in your calculator is you would have to do your alpha y equal I'm going to pull mine out so I can show you real quick. Okay, so what you're going to have to do here, you're going to do alpha, y, enter. So you're going to do open bracket, 9.0 times 10, caret 9. Close your bracket, open your bracket, 2.0 times 10, caret negative 4. And I'm going to close my bracket, open bracket, 8.0 times 10, caret to negative 4. Close my bracket, go down, and I'm going to do 0.30, close bracket, and then caret squared. And once I get that done, I get my answer, which is 1.6 times 10 to the 4th. Now, does anybody have any questions?
Now we create.
Okay, and then I'll have this online too so you can see it. But I wanted to make sure, I wanted to check with the first one first, and then we will go over the next one. So I'm going to go ahead and plug the overhead back in so that you can see it. And like I said, I'm going to try to fix the problem of not being able to hear you tomorrow. So we're going to now look at question number 10. Okay. Question number 10 says, a negative charge of a negative 6.0 times 10 to the negative 6 exerts an active force of 65 newtons on the second charge that is 0.050 meters away. What is the magnitude of the second charge? So what we're going to do this time is we take our original formula that we have, but what we're looking for is we're looking for this right here, which is our QB. So since we're looking for our QB, we have to change our equation to QB equals force, which is our F, and we're going to change that, and we're going to actually take this radius AB squared, and that goes on the top, and then our KQA is going to be on our bottom. So this right here is the equation that we're going to use because we have to modify because we are looking for the second charge. To be able to get that, what you're going to do is you're going to take 65, and based on that, that is 65 newtons is our attractive force. We're going to multiply that by 0.50 meters away. That's our second charge, and we're going to square it. We're going to take our K constant and times that by our QA. And it says in our book that it's negative 6.0 times 10 to the negative 6. And what we're going to do now is we're going to put that in our calculator. Now, putting that in our calculator, so give me a second. So now what I'm going to do is I'm going to take my calculator and I'm going to say, all right, so it's 65. So I'm going to do alpha y enter, open bracket 65 times 0.5, I think it's 0.50. Let me check real quick with my book. Yep, it is. And I'm going to go ahead and close my bracket, and I'm going to square that. And then I'm going to divide that by, open bracket, 9.0 times 10, caret 9, over, close my bracket, and I'm going to multiply that by my 6.0 times 10 to the negative 6 is what it says. So I'm going to make sure that's it, which is my first charge. Yep. And I'm going to do negative 6 And when I do that, I get my 3.009 times 10 to the negative 6. And I just went ahead and changed the sign. And then I changed it to 3.0. And that's how you do number 10. Questions about number 10? Everybody good so far? The gray part, those are the two hard ones. The other two are just answers. So what I'm going to do is I'm going to go ahead and share my screen again with you. And we are going to do number 11 and number 12. For number 11, it says, suppose you replace a charge on B in example problem 1 with a charge of plus 3.0 microcoulombs. Diagram the new solution and find the net force of A. The magnitude of the force remains the same. The direction change is 42 degrees. That's the important one. And your axis is negative 138 counterwise, and they're both on the positive axis. So for number 11, if you have 42 degrees as directional change, that your axis is 138, and that you have a positive on the x-axis, that will be acceptable for number 11. Number 12 says, describe how an electrostatic force between two charges change when the distance between these two charges are triple. The electrostatic force between the two charges is proportional to the inverse square of the distance between those charges. So make sure that you have proportional inverse square of the distance between these charges.
Mr. No.
I am back up. Now, what kind of questions do you have?
Tamisha was trying to ask you something, but I think you was on the a different monitor where where you couldn't hear us.
Yes, sir, exactly right. Yeah, right now what's happening, and I've got to change some kind of setting on my computer where I can use my I guess you want to call this my arm that I have that actually records, and you can actually see my paper.
Yes, ma'am.
Able to do the overhead yet, and I'm working on that, and I'm hoping to have it fixed by tomorrow.
Okay.
Did you have some questions though, Jay?
Tamisha, she wanted to ask you something, but I think she left, and I think she was trying to get to you, but I don't know if she went.
Okay, well, I'll make sure I will reach out to her. I know I'm kind of going fast today, as far as everybody here today, and you get the answers. I did post the picture up for you so that you will have the picture of the notes. But for the math problems, I will have it as a video so you can see it. So what I'm going to do is I'm going to go one by one for everybody that's here. What I have is I have an attendance record from yesterday. I'm doing the same thing today. And what I'll do is I will ask you if you have a question. If you don't have a question, you can say no, and then you can leave. Is everybody understanding what we're doing?
No, ma'am.
Okay, so what we're doing is I'm just asking you if you understand. So, Jeffrey, do you have any questions?
No, ma'am.
Okay, you can go. Trinasia, Little, do you have any questions?
No, ma'am.
All right, baby, you can go.
Okay, bye-bye,
Jay,
y'all.
bye, honey. Jay, do you have any questions? I can't hear. I'm sorry, you're on mute.
No, ma'am, I do not.
Okay, now make sure that you go on Mondays and Tuesdays work, okay, baby?
Got you.
I'm so glad you're back. I was worried about you. Be safe.
I'm good. You too.
Good. Freddie?
No, ma'am.
No questions? Thank you. JP?
Oh, no, ma'am.
All right, you're free to go.
All right.
All right, Jarrett, do you have any questions?
No, ma'am.
And you said Tamisha was on?
Yeah, she was on.
Okay. I'll reach out to her and make sure.
Yes,
So,
ma'am.
anybody else that I'm missing out of your class that wasn't here today?
Gavin, I think.
Yeah, he's very, very sick.
Yeah, that's what they said. He's already been back to the doctor again.
Well, I'm hoping I talked to Abby during because I have them for my lunch group, and I told her she needs to call Tracy Tiller so he can be coded as sick so he won't miss an absence. So we'll see if that goes. But buddy, thank you, Jarrett.
Yes, ma'am.
You turning yesterday's work in.
Yes,
Keep going, buddy. All right.
yes,
Thank
ma'am.
you, honey. Bye.